then you integrate. Just follow these steps and you will do great. First you separate and then you integrate. Just follow these steps and you will do great. First you separate and then you integrate. Just follow these steps and you will do great.
Tis the season to be serving.
When I was solving equations, I was...
All right, so let me set the scene. So we're in class, we're working on integration. So all the students in the class are working on integration. And so I have these two students who begin to argue about their answer on a certain problem. They're both pretty smart students and they got two different answers. And they're arguing about whose answer is right and try to prove to one another who is right. And I'm just kind of listening. They're not being overly loud, but they are kind of debating the veracity of each other's answer. And I try to kind of when things like this happen, kind of let them figure it out amongst themselves versus, putting myself into the problem. But, at one point, one of the students come to me and he came with his paper and he showed me his work and he said, "Mr. Arrington, is this answer correct?" And I looked at it and I said, "Yeah, that's the correct answer." And so it goes back. So the other guy can't believe that guy's answer was correct and his was not. So he comes to me and he shows me his paper and he says, "Mr. Arrington, what did I do wrong?" And then I looked at his paper and I said, "Nothing. Your answer is correct as well." So when I told the second guy his answer was also correct, they were a little bit dumbfounded and thought maybe perhaps I'm just, telling them both correct just to make them happy and appease them. But in fact, they both had the right answer, even though their answers looked different. So let me show you the problem they were working on, or at least a problem similar to the problem they were working on, so you can kind of understand how this all came about. So here's the problem here. So it's the integral of dx over 5x plus 15. So one of the students gave the following answer: 1 over 5 ln of the absolute value of 5x plus 15 plus c. And that's the correct answer. And another student obtained the following answer: 1 over 5 ln of the absolute value of x plus 3 plus c. And that is also the correct answer. So they couldn't understand, and maybe you can't either, how these two can actually be equivalent. So let's take a look. And let's take a look first at this guy and apply some of the properties of logarithms on this guy that kind of show that it's really the same as that guy. So if I may, 1 over 5 ln of the absolute value of 5x plus 15 could be written as 1 over 5 ln of the absolute value of 5 times x plus 3 plus some constant, which based off the properties of logarithms would be 1 over 5 ln 5 plus 1 over 5 ln x plus 3 plus c. Now it's looking more and more like this guy. So we have this 1 over 5 ln absolute value x plus 3. Again, we have here 1 over 5 ln absolute value of x plus 3. But you may say, well, here is just plus c, and here you got plus c, and you also have 1 over 5 ln 5. Well, the deal is 1 over 5 ln 5 is just a constant. And a constant plus another constant is just another constant. This c just means it's a general constant. We don't necessarily know what the constant is, and that the constant could be a variety of things. It just means it's a constant. That's all this plus c means. Well, c plus 1 over 5 ln 5 is also a constant. So this is really the same thing. So 1 over 5 ln 5 plus c is the same thing as c because they're both constants. Now, again, that still is hard for some people to wrap their arms around. So, and the students had a difficult time with this as well. So you can also present it in the following manner. So let's find a definite integral. So let's go, we'll use fairly basic numbers. Let's say we integrate from 0 to 1 dx over 5x plus 15. And we'll evaluate both answers, both antiderivative answers at 1 and 0, and see if they come out to be the same numerically. So our one option is ln of the absolute value of 5x plus 15. I guess I didn't have to write the absolute value because based off the limits of the integral, it's going to be positive. And I'm sorry, and that's 1 over 5. I'll just put the 1 over 5 here. And we'll compare that to 1 over 5 ln x plus 3 to be evaluated from 0 to 1. So you may think there's no way in the world those could be the same. Well, let's look at it. So here we'll have 1 over 5 ln, and if I plug in 1 for x, I'll get 20, and if I plug in 0 for x, I'll get 15. And of course, based off the first fundamental theorem of calculus, those will be subtracted, so it'll be ln 20 minus ln 15. We can write it simply ln 20 over 15. And for this case, 1 over 5. So if I plug in 1 for x, I'll get 4, and 0 for x, I'll get 3. So that'll be 1 over 5 ln 4 over 3. Now, of course, you should notice that 20 over 15 can be simplified. You can divide both those numbers by 5. So that's 1 over 5 ln, yes, you guessed it, 4 over 3. So I submit to you the answer of ln 1/5 ln x plus 3 and 1/5 ln 5x plus 15 are exactly the same answer. In fact, 1/5 ln k times x plus 3, where k is some constant, plus c for the indefinite integral, that would also be the answer. So not just 5 ln 5x plus 15, could have been lx 10x plus 30, etc., so forth and so on. ln 2x plus 6, those are all equivalent, because when you look at it, when you evaluate the definite integral, you're going to eventually put this number as a fraction like this, and whatever it comes to, that factor of k is going to be simplified out anyway. So there you have it, the very controversial problem that seemingly had two different answers that were actually both correct.
Specialized in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section, vocal toe-to-toe, impeccable, splitting your back, son, simple as addition and subtraction, black thought, the infinite relax one.